Hello and welcome back. This is the second part of an episode that I did with Gunnar around chaos engineering within your CI/CD pipeline. And within this session, we are going to look at the actual deployment pipeline, practical examples on how to integrate this within your CI/CD pipeline. And I'm really looking forward to that. So please enjoy and let me know if you have any feedback. So now we're finally going to look at the pipeline. That's what I actually wanted to see. Let's go.
All right. So this application, it's a basic 3-tier application that we are deploying with the help of CodePipeline in this case. And I'm going to show you an example of how we can then add our chaos engineering experiments to this to be able to run it on each deployment that we're doing. So the pipeline, sorry, Johannes, you're not going to get excited by looking at the actual pipeline. It has a few simple steps. We're getting the source from code commit. We're building that source, creating the artifacts, and then we are deploying it to our staging environment. Very straightforward. Mm-hmm. But what we want to do then is to do these experiments that we've previously done manually ad hoc. We want to do them automatically. So what we can do then is to add an experiment stage in our pipeline. And in this case, we're doing it with the help of step functions. So our stage in the pipeline is going to kick off a step functions workflow that helps us to run and then also monitor the experiment. So we can make sure that the experiment either succeeds or if it fails. So let me open step functions. And this is our experiment state machine that we're using.
So you're kicking off a pipeline after the pipeline, kind of. At the end, the step function is nothing but a pipeline, right? It has various steps.
No, exactly. It's a workflow in the same way. So, and the reason for doing it this way is that we want to be able to, if we look at this pipeline, we want to start our experiment. And then if the start is successful, we want to wait for the experiment to finish. And CodePipeline in this case, it can't wait for an experiment. We could get it to start the experiment, but it couldn't wait for the experiment to finish on itself. So that's why we're using step functions in this case.
And that this is then a step function that could be used by anyone, right? So we could open source that piece as well, in a sense.
Yes.
Because starting an experiment and waiting for the result is kind of something we would need to do regardless of the CI/CD tool that we actually use.
Yes, and I think that's the important part here. It's not about, once again, sorry, it's not about the pipeline or what that pipeline looks like. It's about thinking about how we could actually use this. And this state machine, that's available on GitHub, so we can share the link to that as well. So as long as you have a pipeline that's able to kick off this state machine and then wait for the result from it, yes, you could implement this in your pipeline as well.
Yeah,
so
that's also kind of explains. So if I want to trigger this from CodeCatalyst somehow, there is no possibility to natively trigger step functions today, right? So that means I somehow need to work around that. So it's not as easy as with code build to initiate a step function from other CI/CD tools, right? So
CodePipeline has an easy way of using the step functions integration, and there are ways to do it with most tools, I would say. Just need to find how to be able to then start it is the easy thing, but then getting the result back of it so you don't move on without knowing if it succeeded or failed.
Yeah,
I think that's the thing that might need some tweaking depending on the tool you're using.
Yeah, that's true.
So we're waiting for the experiment. So depending on the experiment we're using, it might take a few seconds or it might take minutes. If you want to test something like, for instance, CPU stress, you don't want to do that for 10 seconds. You want to do that for multiple minutes, likely, to be able to actually see that it has an impact on your application. But then as soon as the experiment is done, no matter if it's a success or a fail, the step function workflow ends and then reports the status back to our pipeline. Mm-hmm. So this is a generic construct. It takes, if we go back to FIS, it takes an experiment template ID as an input, and that ID is then what's going to be used. So it's going to kick off an experiment based on the ID of the experiment template. So you could use it for all different types of pipelines as long as you feed it an experiment template ID.
And this could now also be part of my infrastructure as code that I deployed before that, right?
Yes.
Okay, cool.
Exactly.
Yeah.
So if we want to test this out, then let's open, because this has been deployed as infrastructure as code, just to make you a bit happy. So let's open this. And what I do then is I update my stack. Contains a bunch of stuff, but one of the things it contains is my experiment template ID. And in this case, my pipeline has a staging experiment stage. I could also add one after production if I want as well, or any other type of environment. So now we can simply take one of our experiment templates. I have a bunch of them. Let's say we want to do CPU stress. I've created one since before. Then I can paste that ID in and update my stack. No updates are to be performed. All right. I guess it was the same.
The same template.
Gods. I already had the right template ID. Let me just double check it. I did. All right, cool. So it is the correct one. And then, of course, the next step would be to release a change. So let's release the latest code. And this will then go through the steps to first get the source, build it, and then deploy that to our staging environment before it kicks off our experiment.
So this is now once again deploying out the 3-tier application that we talked about, right? So this has some EC2 instances behind?
Yes, in this case, it's EC2 instances, but it could also be any other type of compute. So we could do this on containers, and we could use, for instance, the ECS actions or the EKS actions, or we could do it to Lambda, and we could use one of the options for doing chaos engineering on our Lambda environment as well.
Yeah, sounds like more stuff we could do here as well, right? So
oh yes, for sure. And yeah, and the important part with this then is making sure that this is automatic. So we need to have ways to make sure that our experiment either fails or succeeds. So we need to have those stop conditions in place with CloudWatch alarms. We need to have something that then tells us if it was a successful experiment or not, because otherwise we can't really automate an experiment if we don't know by automation that it actually works. Let's wait for code build to finish.
Can we add some information around costs for using FAS, kind of? So if I run these experiments, like a small one would be definitely easy, but others might be expensive, right, or not?
So yes, when it comes to AWS FAS, you're paying for the experiment time. So shorter experiments cost less because basically using less compute time for FIS. If you run experiments over a longer period of time, you then pay for that period of time.
And is there a free tier that I can use to try out whether this is helpful for me or not?
I believe there is free tier to begin with.
We can look that up and then add it to the show notes, but I think that would be interesting if I want to look at using this and trying it out, right? And then also seeing if there's an impact for my application, then it would be good to have those informations, I think.
Definitely. All right, code build is still working. In the meantime, let's open CloudWatch, where we have our alarm.
You're doing this out of Ohio is what I'm seeing, but FIS is available in all regions today, right?
It is. So I have these environments set up in pretty much every region by now, so I wanted to use one that was fairly clean, and Ohio was the choice today.
That's totally fine. I was just checking the box that it can
available.
Be used in all or most of the regions.
Yes, I would say most. There is a few regions where I think it hasn't been rolled out yet, some of the newer regions, but in the most used regions, it is definitely available. So we have these alarms in place, and one of them is this, which is the one that we added to that template as well. This is a canary, so basically checking the application every minute to make sure that the application responds. And in this case, it's checking that a certain text is available on the application page. So now let's switch back to our pipeline. Code build is done, staging is deployed, and now it's kicked off the experiment stage. So if we then switch to step functions, we should see that we have an execution running. And what's happening is that it started the experiment, and now it's waiting for the experiment. So basically a loop that it's waiting for the experiment to finish. If we then check FIS, we can see that we have one experiment running, which is our CPU stress experiment. So it's now doing CPU stress on the instances.
That means that FIS is producing load on the instance, or does this mean that you're using the control plane to up the CPU part?
So in this case, AWS FIS is making use of SSM documents. So it is executing an SSM document on the EC2 instance, and that document contains basically a few set of commands to increase the CPU load through an application ng stress, I think it's called.
Okay, so this then means that the prerequisite for using this type of event of test is that on the EC2 instances we do have the SSM agent activated and installed, right? And
yes.
And that the corresponding IAM roles needs to have permissions to invoke those SSM actions or documents on the corresponding EC2 instances as well. Okay,
that is correct. So depending on the action, there are different permissions you need or prerequisites you need to have in place. Certain things happen on the data plane, certain things happen on the control plane, depending on the action that you're using.
And that's where demos are always easy, right? Because you can walk something through that you have prepared, but if you're then trying to get this within your own pipeline, you need to get all of those prerequisites checked at the end, right?
That is true. Yeah. But I have to say, I am perhaps biased, but the FIS documentation is superb when it comes to this. So it helps you find what types of permissions you need. And as always, we want to use least privilege, so we don't give the role more access than it needs to have. All right, so this is going to run for 5 minutes, which takes a while. But in the meantime, the step functions workflow continues to simply wait for this to finish. And as soon as it's finished, it's going to report back the status.
So this means if we now go to the EC2 instances that we have running, we should be seeing kind of CPU load already?
Yes, exactly. So if we were to connect into one of the instances, we could see CPU load. We could possibly see it to graphs as well. But yes, they are now under load. And if we had, for instance, a system that is sensitive to CPU load, that could mean that we are then seeing effects from it. In our case, that is likely not the case, since the application is still okay according to our monitoring. So what we could do then, now it's completed. Let's see. It should then fairly quickly update this. And then see if it's successful or if it's not, and then report back. But what we could do now, if an alarm sets off, is that it would then stop the step functions workflow. It would then report back failure, and it would then stop that pipeline from moving forward. because the next step in our pipeline would be, if this is green, it would then deploy the same artifacts into production. But if it fails, well, it should stop there. It shouldn't move on and deploy this into production.
Gonna try to ask my question from a little bit earlier again. Now, while running this experiment, if I would want to see how my application reacts to that experiment, would I need to execute, let's say, Cypress tests or something like that at the same time to kind of verify how the application behaves? So I could imagine, like, I want to have an experiment which puts the CPU load to 40%. How does that impact my application? Then I kind of need to put two steps at the same time, right?
So my answer to that is that you should have that observability into your application all the time, no matter if it's running an experiment or not. So this is part of that monitoring phase of the continuous resilience, having those dashboards, alarms, metrics, and so on in place. And the thing is that it, from an end user perspective, it doesn't really matter if CPU levels are high or low or whatever they are, if you're using 5 instances or 10 instances. From the end user, it's basically if the application works as expected or not. So your observability into the application, you should have that in place to be able to see the impact of your experiments.
I understand, but where are the users in this test? So at the moment on the environment, there is no user that is kind of being impacted by the experiment itself.
Yeah.
And that's what
Right.
what I was trying to get to is we somehow also need to produce user load on the environment that we're testing, right?
So yes, so if you're running it in a pre-production environment where you don't have users actually using the application, what you can do and what we see customers doing is that they add load. So use load testing tools to produce that, or use canaries that have predefined actions that they're doing on the application. And those tools aren't then they aren't there to overload the system like you perhaps do with stress testing. It's about just generating user data or user behavior on the application. So yes, that is correct.
And so from your experience, do you think that would be a stage in the pipeline, or would this be a stage in that step function? Because you could also. So what would be your advice?
So yeah, for automating it, you then need to include it in either or. I would say that it should be part of the step functions workflow in that case. So it's part of when you're starting your experiment, it would basically be steps in that workflow to start the load before it starts the experiment. And then at the same time as when the experiment finishes, it would then stop the load before it then reports back to the pipeline.
This sounds like a cool pattern to look up in the server's lands, or at least to edit there if it's not yet there. So sure. Cool, thanks. So now we see that the experiment finished, right?
It did. So that's good. It succeeded, and we don't have the deploy to production stage, but what would happen is that it would move on to then do the next stages in our pipeline, as long as it's green succeeded, as in this case.
And the success criteria here is that the experiment terminated, or is it that we did not hit that threshold in that CloudWatch alarm?
Yeah, so in this case, it is that the experiment state moved into completed, so it's green. Mm-hmm. So if something had failed, so it moved into one of the failed states, it would then report that to the functions that would report it to CodePipeline.
Okay, but so I could also make, so if you go back to the step function, I think, there was somewhere, there is this fail stage, right?
Yes.
This fail stage could be a CloudWatch alarm that I did not expect got triggered as part of this experiment, and because of that, I want to fail. Is that my understanding correct?
So do you mean if I had added a CloudWatch alarm here as a stop condition, that if that was triggered, it would be failed here, which would move it into the failed stage here. which would then fail the pipeline.
Okay, and that would then mean that the code snippet that Gunnar just added broke my application, and now you need to redo that. Cool. Yeah, that's what I wanted to hear. Yeah, awesome.
Yeah, and we could even do that. So our repo is in code commit, as I mentioned. So we have the application, and let's see if I can find it. Oops. It is in views.
I'm going to distract you, while you're searching, because I think this is a great idea to put into a blueprint in CodeCatalyst. So I'm a little bit biased towards using CodeCatalyst, and it would be cool to have a chaos engineering blueprint over there.
Yeah, I like that idea. That's definitely something that we could look into.
Yeah, or giving end users the possibility to create custom blueprints, right? That would be cool. Then anyone could create that kind of stuff. So I'm really looking forward to see what the CodeCatalyst team has there to bring for us in the next month.
Yes. So no, but I think having that available in CodeCatalyst, yes, I think that's a great idea.
It makes it more accessible at the end, right? So what did you change now? You just changed something.
I just changed the title of the application in this case. Because as I said before, our CloudWatch alarm checks for a text on the web page. In this case, it's checking for the title. So I just added a change to it. Mm-hmm. This will now trigger a new deployment, which is being built. So we'll have to wait for code build just for a bit. And this will then go through the same things. It will then deploy this to staging and then start the experiment. And in this case, since I deployed a bug into my code, which in this case is just a typo, we should hopefully be able to catch that through our CloudWatch alarm.
Yeah, so this week we released the new website for the AWS Community Day in Germany, and we also released the registration. The registration for the Community Day is now opened up, and actually we deployed a typo right a few minutes before we went into kind of live, right? So that was a pity, but we did catch it before we actually went live. So.
Few stressful moments.
Yeah, as long as it's just as long as you have a pipeline that continuously deploys, right, and you can directly react on something, then that's easy.
Yep. So so going back to those safeguards and using them. So it's a matter of thinking about what type of safeguards you need to have for your application. We're just adding one CloudWatch alarm in this case, but it could, of course, be multiple, and that would probably be the case for a production environment as well. And just like with everything else, you want to be able to have a pretty much identical environment in whatever pre-production environments you have as well. So the alarms are the same, that you're able to then catch errors with alarms as well. Because in this case, my CloudWatch alarm should be triggered because I made a change that is breaking in this case. But quite common with chaos engineering is that instead of finding issues with the infrastructure or with the code, with the actual application, we find things that are missing around the support system. Maybe we don't have alarms in place to be able to catch these errors. So when we've done the experiment, nothing alarmed us. We didn't have any alerts, but we saw that something failed. Well, that's a learning for us. We've learned something new about the application. We need to have alarms in place for this thing that could happen. So we then improve that, we add that alarm, and then as soon as we have that in place, we're able to then test the same experiment again and verify that that alarm actually worked as it was intended to. So it's very common that you find other things, unexpected things, when doing these types of experiments.
And is FIS today smart enough to then advise on what additional alarms you would need or what additional verifications you should add to your application?
AWS FIS does not provide that type of guidance, but instead we have a service called AWS Resilience Hub, which is a service that then focuses more on that. So it makes use of many of the best practices we have in the well-architected framework and so on to then not only help you look at your application from a resilience perspective, but it also then can guide you. If your application based on infrastructure as code or based on the tagging, resource groups and so on, if it looks like this, well, maybe you should make these changes to make it more resilient. And alarms, for instance, is one of them. But it will also suggest chaos engineering experiments that you can run on your application.
Cool.
All right, so we've moved into the experiment stage now. So we hopefully have a new execution that's running. And while that's running, we also have a new experiment running. And then it's just a matter of seeing if our CloudWatch alarm picks up that issue. So far it hasn't. This is a demo, so
yeah, you never know what happens in demos, right?
Yep. So
yeah, I was
this one.
Sorry.
Yeah, sorry. It runs every minute, so it'll take a bit of time before it picks up the issue.
I was giving a demo on the user group in Munich on Tuesday, and actually I failed to save a Git commit because I did not think about escape $WQ and then an exclamation mark. Yep. I did not get out of the commit message, but luckily the audience was there to help me. But that's what happens in demos, right? You sometimes don't know what happens.
If you're using Vim, I think you have yourself to blame in that case.
I was using Nano, but it was still the same problem.
Oh yeah, that's actually. Nano. That's Nano. That's right.
I don't know.
Well, still.
And I recently moved from Windows to Mac, so I really I'm still struggling with all of those command changes and stuff like that.
All right, let's see. Checking back on my alarm. Still okay. Oh, that's worrying. Maybe we don't have alarms in place. So this is going to be the learning for us.
That's okay. And I think that's what we could add from a demonstration perspective. But I think the idea is clear, right? This alarm would now trigger. Now the pipeline would then actually, the experiment would fail. Because of the experiment failing, we would send back the failed state of the step function. And we would then go back to the pipeline, which would receive that failed state and would then abort the pipeline. I think that's what I understood. But I wouldn't want to wait another 5 minutes to look at that, Gunnar. So if you don't mind, let's just go back to stop sharing the screen. Let's do kind of a wrap up.
Yes.
Cool. So yeah, let's try to sum up a little bit. What's our advice for anyone interested in doing chaos engineering?
First off,
go ahead. Sorry.
Yeah, the first step is to just assume that things are going to fail in your application. We all know that they do. We perhaps hope that they won't, but assume things to fail. And then use chaos engineering as a way to test if your application could be resistant to these types of failure. Mm-hmm. So use chaos engineering, test the different types of failure modes you can think of. You can use previous failures that you've had, do them over again to see if you have improved your application, or just think of other things that could fail. And then the next step is to think about how to automate it and using it as part of your pipelines. I think that is the best way to automate chaos engineering, because then you will do these experiments on the frequency that you want. If it is on every code deploy or every deployment into a specific environment, for instance, you can run these experiments. And we included one experiment, but it could include multiple experiments. It could include multiple actions and so on to do these experiments. So my advice is to try out chaos engineering, perhaps not automate it at first. You want to get used to the practice of chaos engineering, but then make sure to then try to automate it, include it in your pipelines in, for instance, the way that we did in this demo.
Thank you. Another question on that regards is that there is something that is called the DPRA that AWS announced last year, which is the Deployment Pipeline Reference Implementation. In that DPRA, chaos engineering today does not really play a role. Do you think that's something that should be added over there? So my question at the end is, should chaos engineering be part of every mature CI/CD pipeline?
I don't think I should say yes to that, because there's always going to be the edge cases. But I would say that if your organization wants to make sure that what you're deploying is more resilient to failure, then yes. I believe chaos engineering should be part of mature pipelines if you want to make sure that you are as resilient to failure as possible and that you keep improving your applications.
Cool. Yeah, that makes sense. It's kind of in line with what I think. I do believe that chaos engineering plays a big role in mature pipelines and also in mature applications at the end, right? But when you start or kick something off, you will not directly benefit from having that extra step within your pipeline, especially as even if it just takes 2 minutes, the pipeline will be 2 minutes slower, right?
Yeah.
Which will reduce the developer productivity, or at least the possibility to add value to the production environment. So that's where I think, yes, it's a step, and yes, you can and should add it, but at a later stage of your project would be my advice, at least.
Yeah, I think that makes sense. And in the earlier stages of the project, you can instead do it more ad hoc. You can do manual experiments to complement what you're building.
Yes, that's true. Awesome, Gunnar. Thank you so much. This has been great. Took a lot of details away from the session, and I hope that the audience also does. And it was a pleasure.
All right. Thank you very much.
Looking forward to hopefully see you again soon. Last but not least in Vegas, right? Maybe. Yes. Looking forward to do more collaboration with you if possible. And I'll ask you for all of the links that we discussed so we can add them to the show notes.
All right. Thank you so much. Thank you very much, Johannes.
Bye-bye.
Bye-bye.